2. Find all the unknown angles to the nearest degree and all the unknown side length to the nearest tenth of a unit. Okay. Question A. We have a 90-degree angle. We know this side is 13. We know this side is 15. We could use Pythagorean theorem. This side's actually equal to 15 square minus 13 square, if we wanted to. But we're not going to do that. We're not going to do that. What we're going to do instead is try and find this or this angle. And let's call this, well, they're already called ABC. So how am I going to find angle A? Well, in terms of angle A, 15 is a hypotenuse. Let's write it down. SOH CAH TOA. So when we're looking at 18A, 15 is a hypotenuse, and 13 is adjacent hypotenuse. So we're going to use cos. Cos of A is equal to adjacent over hypotenuse, which means A is going to equal to cos, inverse cos, 13 over 15. And we're going to solve for that. Inverse cos 13 over 15. Divided by 15. And it is 30 degrees approximately. Just under 30 degrees, which would make this 60. But we're going to solve this a different way. So let's just say we don't know that it's 30 degrees there. Let's say we did C first, because we could have done C first. How would we solve for C? Well, 13 is opposite C, and 15 is adjacent, is hypotenuse. So we have opposite and hypotenuse. Opposite, hypotenuse. So we're going to use sine. Sine of C equals opposite, 13 over 15. Let's write that a little nicer. 13 over 15. So then C is going to equal inverse sine 13 over 15. So let's try that. Inverse sine 13 over 15. Whoops. Well, we end up getting C equals just over 60 degrees. Okay, now we have all the angles. What about this side? Well, depending on what angle we use, we could use Pythagorean theorem. We're not going to. What we're going to do instead is, well, we're going to use 30 degrees. And we have the opposite, sorry, the adjacent and the opposite. Well, opposite and adjacent uses tan, TOA. Right, so we're going to say tan of 30 degrees. What's adjacent? Opposite. What's opposite of adjacent? We don't know. And adjacent is 13, right here. So let's solve. Tan of 30 degrees, multiply both sides by 13. 13, tan of 30 equals opposite. So then, 13 times tan of 30. 13 times tan of 30. 7.5. Opposite equals 7.5. And we have everything we need. We know everything about our triangle. Okay? Let's look at question B. Question B. Seven and 9. So we have, let's say we want HI, GHI. All right, let's look at I. Angle I, what do we have? We have opposite. We have adjacent. Let's look at that. SOH CAH TOA. Sine, to use sine we need opposite and hypotenuse. We don't have that. To use cosine we need adjacent and hypotenuse. We don't have hypotenuse, so we can't use the whole thing. In tan, for tan ratio, we need opposite and adjacent. We have it. That's what we're going to use. So tan of I equals opposite, 7 over adjacent, 9. So that means I is equal to inverse tan, 7 over 9. Let's try that out. $38 approximately. I equals 38 degrees. Now, I'm not going to do it the long way. I'm going to do it the short way. I'm going to save as much time as possible. That's 38 degrees. Yes? That would make this 90 minus 38, or 180 minus 90, which is 90, minus 38. And that's equal to 52. So that's going to end up equaling 52 degrees. And this side is going to be 7 square plus 9 square, and take the square root. But actually, to be honest, since we're learning how to use sine, we're going to use the long way. We're going to use, not the long way, but we're going to learn to use tan and sine and cosine. So now that I have, let's say I didn't solve for I and I wanted G, right? I wanted angle G. Now the opposite is 9 and adjacent is 7. So tan of G equals opposite, which is 9, over adjacent, which is 7. See how they're flipped? That means G is equal to 9 over 7. 9 over 7. Inverse tan 9 over 7. The answer is 52, which is what I got initially anyway. 52 degrees. And now let's solve for hypotenuse. And we can use cos, the cos ratio or the sine ratio. Let's get this out of here. Also this. Okay, let's use the cos ratio. There's two ways to get this hypotenuse. There's two ways to get hypotenuse. And the way to get it is, cos of, it doesn't matter, 52 degrees equals adjacent 7 over hypotenuse. Or I could have done cos of 38 degrees equals adjacent 9 over hypotenuse. It really didn't matter. Or I could have used sine of 52 degrees. Sine of 52 degrees equals opposite 9 over hypotenuse. Or I could have used sine of 38 degrees. What's opposite of 38? 7 over hypotenuse. Any one of these will give me my answer. So let's just pick one of them and do it. Let's just do this one. Multiply both sides by hypotenuse. There. And divide both sides by sine of 52. Hypotenuse equals 9 over sine of 52 degrees. So let's try that. 9 divided by 9 divided by sine of 52 degrees equals 11.42. Hypotenuse equals 11.4. 11.4. Now, let's compare that to Pythagorean theorem. 9 squared plus 7 squared take the square root equals hypotenuse, right? Let's try that. Clear all. 81, that's 9 square, plus 49, 7 square, equals square root, the answer, 11.4. Is that what I got? Yes, it is. So we can feel pretty confident that it's giving us the same answer. All right, question C. We're just going to do this real fast as we can. So I have a 90-degree angle there. This is 6 centimeters. This is 5 centimeters. Okay, what do we have? We have hypotenuse. Let's see, let's say we want L. Because this 5 is defined by what angle we choose to work from. J, K, L. So let's say I have L. Let's work with SOH CAH TOA. SOH CAH TOA. Now, L is adjacent to 5. So I need something with adjacent and hypotenuse. That's cosine. So cos of L is equal to adjacent over hypotenuse, which means L is equal to inverse cos 5 over 6. Let's try that. Five divided by 6. Whoops. 33.5 and change, right? 33.55. Let's just call it 34. L equals 34. So that's 34 degrees, which would make this 56 degrees. And this side is just going to equal to, let's just pick any angle. So 56 degrees. Let's look at this. 56 degrees, and our adjacent is going to be unknown. We're going to want our adjacent to 56, and opposite is 5. So tan, we're going to use, look at SOH CAH TOA. SOH CAH TOA. We need opposite and adjacent. No, not working with hypotenuse. Opposite, adjacent, yay. We're going to use tan. Tan of 56 degrees equals opposite 5 over adjacent. So let's solve. Adjacent, let's multiply both sides by adjacent. ADJ, boom, boom. Let's divide by tan of 56, 5 over tan of 56 degrees. ADJ equals 5 over tan of 56. 5 divided by tan of 56 equals 3.4. 3.4 centimeters. So that's our self-triangle, 3.4 centimeters.